Alright, in this video we're going to be talking about systems of equations in three variables. When we have three variables in an equation, this is a plane. So a plane being three-dimensional now. A solution to a system of equations is when those three planes intersect either in a point where we have one single solution or a line where the answer is a linear equation, or they could be the exact same plane, in which case there are infinitely many pairs or ordered triplets to this as a solution. It could be possible that those planes intersect in such a way that there is no common area. There's common to two planes here, two planes there, but never three planes all at the same time. Or the planes could be parallel and they would never intersect at any point. If the planes intersect along a common line, the equations are considered dependent. So they are dependent on each other, and the system is consistent. So that word consistent means that there is a solution. Okay, so there is an infinite number of solutions in this case because that line will continue on and on forever in both directions, but there is a solution. So that word consistent means there's a solution. If the planes coincide, they are also considered dependent. The equations are dependent and consistent. Again, there are many number of solutions, so it's consistent. Again, consistent means there is at least one solution, if not infinitely many. This third scenario over here says the two planes coincide and the third is parallel. So the equations are dependent, right? These two that are the same are dependent, and the system is inconsistent. So because these are parallel, they'll never all three have a common point, and it's inconsistent. So no solution would be inconsistent. A solution or infinitely many solutions is consistent. Let's look at an example of how we determine whether or not this ordered triplet, right? There's three now instead of an ordered pair. There's an x, y, and z. We want to know if that ordered triplet is a solution to this system of equations. Well, since our ordered triplet goes x, y, z, all we have to do is plug those into all three equations, and if they end up with true statements, then that is a solution to the system. If one of them is false, just one of the three has to be false, it is not a solution, meaning it is not a common point for all three planes. So using just the first equation here, I'm replacing x with 2, replacing y with a -1, and replacing z with 3. 2 plus -1 is a +1, plus 3. Does that equal 4? Yes, that is true. So it works for the first equation. We need to try the second equation. I am replacing x again with 2. I'm replacing y with a -1 and replacing z with 3. I need to know if this will end up true. 2 times 2 is 4. I can do a -2 times a -1 gives me +2 if I use both of those negatives. 4 plus 2 is 6 minus 3. So 6 minus 3, does that equal 3? Yes, it does. This is also true. So again, this is a question until we know whether or not it's true. And now the last equation here, I'm going to replace x with 2, y with a -1, and z with 3. I want to know if that's going to equal -3. Again, this is a question. So -4 times 2 is -8. And 2 times 3 is 6. Going left to right, -8 plus 1 is -9 plus 6. Will that equal -3? Yes, it does. That is also true. Since when I plugged in that ordered triplet to all three of the equations, they ended up with true statements, yes, it is a solution. So in this case, since there is a solution, we do know that that system is consistent. There could be more than one solution, so it could be a dependent system, but we don't know yet. All we know is that that particular point is a solution to this system.